So, today kita akan belajar a very simple topic. I think most of you guys already expert of this topic by now. Is molecular shape. Macam kenal Kau nampak kat mana? Okay. Okay. So, everyone I think dah tengok all of this and this is basically apa yang assignment korang suruh buat lah. So, explain the valence shell electron pair repulsion theory ni, I think everyone hopefully dah memorize. Yes. Because it's easy kan, kita salin je. Wah, nama korang hebat-hebat, anak muda korang masuk. Okay. So, and then kita akan draw the basic molecular shape. But now, kita not only will draw the basic, we also draw the distorted shape. Bila central atom ada lone pair, and we will see what will happen to the shape. And then this is basically our tutorial, predict and explain the shape of the molecule and the bond angles in given species. I got one question. Have you guys download and print out the CAP handout?
Yes.
So for those who already download and print it out, good. Because senang nanti kita nak lukis, I'll lukis together. But if you guys siapa yang tak print lagi, make sure take out around 4 piece of paper because kita nak lukis. Because the handout tu just a table to make everything tidy lah. Okay, boleh. So, kita akan go to our slide. So, the first thing yang kita akan belajar is VSEPR. So, orang cakap VSEPR ni, you dah tahu dah. Is basically why kita dapat macam you guys lukis tu ada tetrahedral lah, ada trigonal planar lah. Kenapa you guys dapat those things is because kalau you ingat, elektron tu charge dia apa?
Negative.
Yes, negative and negative charge will repel each other. So, same as electron pairs, so they duduk together kan, in pairs. So, it will tend to push other electron pairs as far as possible. Probably lagi jauh, lagi bagus untuk minimize the repulsion. Dia tak suka duduk dekat-dekat. Okay, macam kalau you ada magnet yang the same poles, you letak, you lagi dekat lagi dah susah kan, you nak tolak kan. Same thing as electrons. So, this is an example. Okay, a linear and then bila kita tambah lagi lone pairs, nampak tak? Dia bergerak untuk go away from the other existing lone pairs. Okay, let's see this animation again. So when we have 1, we have 2 lone pairs, we have 3, we have 4. It can be lone pairs ataupun bonding pairs. Itu kita dah buat Lewis structure kan. You can get, kalau bonding pair tu maksudnya kalau bond tu pun ada 2 elektron kan. Betul tak? So nampak? When a new pairs of electron, tak kisahlah bonding ke, lone pair ke, ada pairs of electron will move away. Okay, dia tak suka duduk dekat-dekat ni. Okay. So, we go on to the next one. Strength of repulsion. So, kalau you tengok, kenapa kalau you buka you punya buku nota, buku surat 72 if I'm not mistaken. So, 72, kalau you tengok kenapa dia ada beza shape dia from 71, 72 and 73, you tengok dengan buku surat 71. Kenapa dia ada beza dia? Okay, because the strength of repulsion is different. Okay, kalau lone pair tolak dengan lone pair is way higher than kalau lone pair tolak dengan bonding pair versus bonding pair dengan bonding pair. Okay, decrease the repulsion force. Okay, inilah the definition of VSEPR yang you guys tulis tu. Ingat tak? You guys tulis you guys cakap it determines the orientation of the atoms kan in space. Okay. So what it say is, kalau carbon dia ada 2 lone pairs versus carbon dia ada 1 lone pair and then a bond versus carbon dia ada 2 bonds. Okay, kalau lone pairs kita draw like this, sebab kalau ingat tak definition of orbital kita belajar dulu?
3-dimensional space.
Yes.
That's around.
Yes. So it's a 3D space around nucleus where the probability of finding an electron is the highest. So what kita lukis ni sebenarnya yang nampak macam hantu sebenarnya is a space. So this 2 pairs is 2 electron ni in lone pair ni can be anywhere around here lah. So doesn't have to be accurate lah. Kalau you lukis the lone pair and then you buat around macam P-shape orbital pun dah okay. Okay. So the strength of repulsion is this repulsion between lone pair and lone pair is the highest, paling tinggi. While kalau lone pair nak tolak dengan bonding pair is the second, dia kurang sikit daripada the lone pair dan lone pair, and kalau bonding pair and bonding pair is the weakest. Okay. There's a reason why we have this order of repulsive force. Okay. Sebab kalau you ingat, when bonding, the atoms are shared. Okay. So, the electron are shared. The electron here and here are shared between the carbon and the terminal atom. X ni boleh jadi apa-apa atom. Okay, so when it is shared, the electron, okay, bentuk yang orbital tu, okay, kalau lone pair bentuk dia macam ni, dia duduk sini dan sini. Kalau bonding, dia punya electron punya clouds akan lebih kecil and thinner. Sometimes kalau X ni adalah electronegative atom, contohnya fluorine, the carbon and fluorine, all of the electron will be more dekat fluorine than dekat carbon. Banyak elektron tu duduk dekat fluorine daripada dekat carbon. So that's why kalau you tengok kenapa bonding lone pair push harder than the bonding pair, sebab bonding pair ni electron is spread out in a bigger area. Rather than kalau dekat lone pair ni basically kat sini je lah, dia macam membesar kat sini. Okay, boleh? Boleh tak? Saya tak nampak korang.
Boleh. Kami doa lagi.
Okay. Saya tak nampak slide je. Korang angguk lah besok pun saya tak tahu. Okay, so now kita akan tengok to the molecular geometry yang korang suka sangat lukis tu dekat assignment korang tu. So the first step is draw the Lewis structure. Satu assignment korang, kalau you guys tengok, dia tanya valence electron dulu, and then dia suruh lukis Lewis structure kan. Okay, because kalau you ingat hari tu nak lukis Lewis structure, the very first thing you guys have to do is count the valence electron, because valence electron is the only electron that involved in bonding. Inner electron kita tak kacau pun. Okay, and then second step is count the electron pairs bonding and lone pairs. Okay, yang ini kita tengok lepas daripada kita dah buat Lewis structure. Kita tengok dekat central atom only. Central atom only. Okay. Sekejap ada kawan korang nak masuk. Okay, and then assign the electron pairs as far as possible to minimize repulsion. This is basically apa tu VSEPR tu. Okay. This is VSEPR. Okay. Valence shell electron. Sekejap. Saya ada salah ni.
VSEPR.
Yes, betul lah. What's okay? Sekejap. Okay then. Okay, sorry for that. So this is VSEPR, Valence shell electron repulsion theory. So the step is very simple. It's just an addition to your Lewis structure. Okay, so and we will see the shape dulu. Saya nak tunjuk, and then kita akan tengok macam mana nak lukis. Okay, the first thing is beryllium dichloride. Okay, the first thing you guys kira dia punya electron valence, and then buat Lewis structure kan. So Lewis structure, you lukis you punya Lewis structure. Okay, one thing yang saya tengok ramai salah. Okay, for an example, kalau barium dichloride ni is 2-, for example lah, contoh. Okay, Lewis structure also okay. Lewis structure also must have bracket and 2-. Sebab kalau you tak ada ni, you can lose up to 2 marks, 1 to 2 marks. Okay, sebab bila dia dah bagi you punya compound is an ionic compound. So tak kira cation ke anion ke, you kena lukis bracket. Kalau you tak tulis bracket ni, you basically just lukis neutral charge. And just to be safe, bila you dah lukis also the molecular geometry, also lukis the bracket. Okay, boleh tak? Okay, ini contoh je lah. Barium dichloride ni bukannya 2-. Okay, boleh. So, okay, cara dia, the first thing is you buat Lewis structure. Second, after you dah lukis Lewis structure tu, you kira bonding or lone pair dekat central atom only. Okay, you tak kisahlah lone pair ke bonding ke, you kira semua. So sekarang dia cuma ada 1 and 2. So that's why dia ada 2 pair. So based on VSEPR, kita nak letak dia as far as possible. So tengah-tengah dia is beryllium. Tengah-tengah dia is beryllium, and then kita letak satu spesies, okay kan, and it is chloride. So when drawing the molecular geometry, dah tak perlu dah nak tulis lone pair yang dekat terminal atom ni, dah tak perlu dah. Skala lone pair ni dah tak perlu dah nak lukis. So if you guys ingat the animation tadi, how kita nak letak the second chlorine to be as far apart as possible from this chlorine? Okay, this is all with the geometry, mathematics. You know, kalau circle, berapa degree in circle?
360.
Yes, 360. So, if you look, doesn't matter where you put, you'll be in the same plane, kan? So, the furthest away nak letak chlorine is the other side. So that's why kalau the molecule with a linear, it is have 180. Not bad. It has 180 degrees. Okay, because it is basically the furthest away you can put this chlorine then to this chlorine. Okay, because kalau kita nak 360 bahagi 2 dapat 180 kan? Betul tak?
Ya.
Okay. So now kita tengok, what if instead of 2 kita ada 3? Kita nak letak mana pula 3? Okay. Kenapa saya tak cerita pasal kalau ada satu je bonding pairs? Okay. Kenapa? Sebab kalau satu je bonding pair dia, contohlah H dengan Cl. Doesn't matter how much, the angle between this is always 180 kan? Sebab a bond, one bond, double bond ke, triple bond ke, angle diorang always straight. Diorang takkan bengkok. Tak ada yang bond, contohnya hidrogen, tak ada hidrogen dia punya bond macam ni. Bond takkan bengkok. Because basically what a bond is one hydrogen is sharing an electron with the other hydrogen. They will share the electron clouds. So, doesn't matter how you put it, they're always in a straight line. Okay, let's see kalau kita ada 3. So, contohnya boron trichloride. You dah buat, dia punya Lewis structure is like this. Okay, Lewis structure dia macam ni. It's normal kan? So, bila you dah lepas buat Lewis structure, you kira berapa banyak bonding, berapa banyak dia punya lone pair dekat central atom only. So, dekat central atom, dia ada berapa bonding pairs? 1, 2, 3.
3.
So, dia ada 3 bonding pairs and berapa lone pairs dekat boron ni? Tak ada kan?
Tak ada.
So, kosong. So, bila kita tengok ada 3, maksudnya kita have to put form tadi tu, contohnya, this is the, kalau you tengok buku, sometimes dia orang letak macam ni. Where A is the central atom, X is the terminal atom. So, form 2, now kita ada 1 extra. So, macam mana kita nak letak the other extra terminal atom and minimize the repulsion between the other 2 existing atoms. So how we do it? Kalau you tengok, same as geometry lagi. 360 divided by 3 will get 120 degrees. So that's why kalau you tengok, the molecule kita akan letak beryllium dekat boron dekat tengah and chlorine dekat 3 penjuru. Okay. Kalau you tengok, this is the last molecule yang betul-betul semua dia punya atom is atas paksi. Okay. Bayangkan dia duduk atas you punya kertas, flat. Okay. That's why kita boleh draw dia as boron. Okay. Make sure you punya bentuk angle tu macam Y lah, because that's how you will show is it is 120 degrees. Chlorine, chlorine, and chlorine. Okay. Because nanti kita tengok kenapa kita guna wedges and dashes. Okay, now kita tengok what happen kalau ada 4 pula. So, contohnya methane. Dia dapat 4 and you buat Lewis structure, you dah dapat macam ni. And bila kita nak letak, so sebabkan atom ni, molekul ni bukan je duduk at 2D je, dia duduk kat 3D. So kita bukan hanya tengok bulat 360 only, kita tengok sphere macam bola. Okay, bayangkan tengah bola awak tu is the central atom and keliling tu is the terminal atom. Macam mana pula awak nak letak dia as far apart as possible? Okay, so mathematician pun kira. So they found out that one angle untuk kalau empat terminal atom, to put them as far apart as possible is 109.5. Okay, this is by hook or by crook, you guys have to remember. Kalau tetrahedral is 109.5. Don't worry, this is the hardest angle yang nak hafal. Yang lain semua senang. Okay, hafal this one. So, cara kita nak lukis molecular geometry, because kalau exam dia orang tanya molecular geometry of CH4, you cannot lukis as pretty as this in that short period amount of time kan. Tak boleh nak buat cantik-cantik, nak buat ni lukis shadow belakang lah, tunjuk di sini belakang, kiri kanan. So, cara nak lukis, bayangkan this is your kertas. Okay, cara kita lukis, kita always bayangkan kita letak molekul tu atas kertas. Okay, the first thing yang kita always letak is the central atom. Okay, sekejap saya lukis ni besar sikit. Okay, this is our kertas. So the first thing is kita letak the central atom. The central atom ni macam kita letak je terus atas kertas tu. So and then for the cara you nak bayangkan this thing. Okay, bayangkan this and this, you guys letak atas kertas. Hydrogen and hydrogen. Okay, now kalau you tengok the other two hydrogen, dia macam terkangkang kan, dia tak duduk dalam sama plane as this kan, tak duduk sama plane as this.
Ya.
Okay, bayangkan this is your paper, nampak tak, satu hydrogen dekat belakang, satu lagi hydrogen dekat depan paper awak tu. So apa yang kita lukis ni is carbon, hydrogen yang betul-betul atas paper awak tu, atas plane awak tu. So cara kalau awak nak represent is you guna wedges and dashes. So wedges, some books boleh tinggal putih, you just buat 3 segi. This one ada 90 degree angle of I think this called acute triangle ke? Correct me if I'm wrong. So, but the most accepted way to represent this is using black wedges. So you draw kan dia hitam, and you tulis hydrogen and hydrogen. So basically apa yang you guys lukis ni is this hydrogen is the same as this hydrogen. So this and this is the same. Mana bila you buat wedges, it represent going in front of the plate. Okay, while kalau kita guna dashes is at the back of the plate. Okay, Okay, boleh. So now I'm gonna show you my camera jap. So if you guys can see this, okay, this is tetrahedral yang you guys buat tu. So apa yang kita lukis tu is you pick any plane, you tak kisah, but it has to involve the central atom. So central atom contohnya cikgu ambil plane base tu. Okay, sekejap, cikgu tukarkan dia punya colour. Okay. So okay, pick any two. You can pilih any molecule. So bayangkan this two is the one in plane. So the central carbon, the hydrogen and hydrogen yang in plane. So in your punya kertas. So bayangkan sebab apa? Bayangkan you punya kertas is this, and you punya the atoms are on the plane, and if you can see, one is going in front of the paper and one is at the back of the paper. Nampak tak? Bayangkan that is the plane. Okay, then baru you draw the dashes. So the wedges is the front of the plane, always depan plane, and the dashes is always belakang of the plane. Okay, that is the easiest way to represent a 3D molecule on a piece of paper. Because a piece of paper kalau you buat macam mana pun it's still 2D kan. You only have height and length. Now you nak represent height, length, and then width. Okay, so you nak bezakan that satu kat depan, satu kat belakang. Okay, so saya tak nak galih because belakang ni ada jawapan untuk assignment awak. So
Ada habuk kan?
no, ada habuk ke? Tak apa, nanti saya cuci. Jangan risau, saya ada vacuum, so don't worry. So now we go on to form 4, kita go to 5 pula. So now we go to 5. 5 contohnya is phosphorus pentachloride. Okay, so the first thing is always you buat Lewis structure, and then you count the bonding pairs and the lone pairs. So bonding pairs kalau you kira dia ada berapa bond? 1, 2, 3, 4, 5. So 5. Lone pairs you tak ada kan? Kat phosphorus tak ada kan? Because what dictates your molecular shape is always the central atom only. So form tetrahedral tadi, you nak tambah lagi satu. What's the best way? Now it's called trigonal planar and dia ada dua angles. Okay, because if you guys can see, kenapa dia cakap trigonal bipyramidal? Bi ni jangan tulis by tau. Because bi ni means dua. Because basically what's the name suggest is you have dua piramid yang bentuk tiga segi. Okay, kalau you tengok nampak tak this? And this, and then this. Okay, and then okay, Nampak tak dia bentuk tiga segi? There's 4 atoms actually producing a pyramidal shape. Okay, and as you can guess, it will produce the same shape dekat belakang. Betul tak? So, dia ibarat dua
Piramid.
yes, dua piramid ditangkup with each other. I have a model here tapi ada cabut tadi. Right. Susah betul hidup. Okay. So that is apparently the best way to arrange 5 atoms where we can minimize the repulsion as much as possible because kita still follow VSEPR theory kan. So, cara nak lukis. Mana my cursor ni? So, cara nak lukis is you pick a plane. So the easiest way, you nampak tak ada bentuk T ni? Okay. Yes, this T can go this direction ke this direction. Doesn't matter. Because kalau you tengok actually, we have 2 different type of orientation. This is actually an axial and this is equatorial. Okay, equatorial tu macam equators. So garisan apa bumi tak, tengah-tengah bumi tu. Okay, so equatorial is basically apa-apa yang horizontal. And axial is apa-apa yang vertical. And this is okay. Kalau you tengok, there's two atoms yang axial, yang dirunduk vertical, and 3 atoms yang duduk dekat equatorial. Okay, so cara nak lukis, ambil any of those bentuk T tu. So contoh this one is phosphorus. Okay, one more thing is kalau the question tanya pasal phosphorus pentachloride, lukislah phosphorus. Jangan lukis what the general, because kalau you tengok dalam buku, dia orang suka tulis guna E and X, betul tak? Okay.
Yeah.
E and X is a general representation of the molecule where E is the central atom, X is the terminal atom. Okay, cara nak lukis the pentachloride. So the first thing you draw the T. Sebab ini adalah dia punya molekul yang in plane, dalam plane. So kalau you tengok, kita ambil this plane yang 1, 2, 3 ni. And tengok, satu dekat belakang plane, satu kat depan plane. So do the same thing. Satu kat depan and satu dekat belakang. Okay, boleh? So I'm going quickly for the common shape. And this one is octahedral. So octahedral. Now instead of ada 5, kita ada 6. So, okay, saya lupa nak terangkan tadi. Bond angle for this octahedral, trigonal pyramid bipyramidal ada 2. Kalau you tengok, this 3, yang 1, 2, 3 ni, jarak dia sama macam trigonal planar. So, itu yang namanya trigonal. Dia bentuk 3 tu. Tapi, kalau you tengok, this one and this one, angle dia is acute, which is 90 degree. Okay, The only weird angle yang you guys kena remember is this. Tetrahedral only. Only tetrahedral je, semua angle dia is 109.5. Okay. Start linear senang kan? Just 180. Just garisan straight lurus. So 180. Trigonal planar dia ada 3. Put as far as possible 100 is, kalau kita nak fikir, is 360 divided by 3. But tetrahedral is the weird one, and trigonal bipyramidal. Okay, you tengok, ingat ada bipyramidal, so ada 2 piramid and also ada 2 bond angle. So kalau dia tanya the bond angle for trigonal bipyramidal, kalau you buat dapat trigonal bipyramidal, jangan pilih mana-mana satu, always tulis dua-dua tu. So bond angle is 90 degree and also 120 degree. There are 2 bond angle because this one and this one is 120. This one and this one 120. This one and this one is also 120. But kalau for the equatorial and the axial is 90 degrees. So this one 90, ini dengan ini 90, ini dengan ini 90, and then this one and this one, this one and this one, this one and this one pun 90. So kita ada 2. Okay, next is the easiest, is one of the easier molecule nak lukis. So kita dapat octahedral and we have 6 terminal atoms. So kalau you tengok, you nak ambil, there's a few ways you guys nak lukis. But the easiest way kalau you guys nak lukis is this. You ambil plane this, plane. Okay, bayangkan this is your paper. So you ada 2 molekul dekat belakang paper awak, while the other 2 molekul is, dia ada 2 molekul dekat depan. 2 molekul belakang, 2 molekul depan. So the first thing is draw the central atom and then draw the terminal atom that is in plane, which is phosphorus. And then you draw, so ada 2 kat depan kan? So draw yang 2 kat depan tu. Kalau black wedges always mean dia dekat depan plane. So phosphorus, and then wedges always mean dekat belakang. So this. Okay, nampak tak? So and then kalau the bond angle, kalau you tengok how many, macam mana you tengok pun semua dia akan 90 degrees. Okay, dekat mana pun within anything is 90 degrees. Okay, boleh?
Boleh ke?
Okay, now kita tengok you punya get handout. Ada tak get handout? So
Ada sir.
yes, so apa yang saya nak kalau korang tengok, this is the jawapan lah basically. I'm not gonna show it to you. Okay, tak sempat tengok. So I'll take a break around 10 minutes. Okay, so siapa yang nak pergi minum air ke, nak pergi tandas ke, you can do so. But siapa yang tak pergi, so what I want to do is kalau you guys tengok you punya get handout, kalau tak ada you guys boleh buat. I want you guys to fill this dekat electron pair geometry. Okay, apa nama-nama dia? So, number of bonding pairs, number of lone pairs, semua tu, mereka shape tu, tinggal dulu. Dan tu kita buat sekali nanti. So, the first thing yang I nak you guys buat is the electron pair geometry. Nama dia. So, kalau dia ada 2 pairs, maksudnya dia bentuk apa? Okay, boleh tak?
Boleh.
So, kita 8:55 kita start balik. Boleh? Okay. Simple je. And then we can nak minum ke apa dulu.
Electron pair geometry sama kan?
Yes. Kalau ditanya electron pair geometry is nama. And dia berbeza dengan molecular shape. Molecular shape pun sometimes ada nama. Electron pair geometry is purely based on berapa banyak pair. Tak kisahlah bonding or lone pair. Tak kisah. So dia campur semua.
Okay.
Okay, we'll continue on 855. So, kita akan sambung buat our get handouts. Okay. So, if you can see that electron, kita ada two names. Satu electron pair geometry, satu is molecular shape. Okay, molecular shape is okay. Okay, molecular shape is after we consider lone pairs. Oh, like that. Sekejap Alamak. Sekejap My words is not functioning. So nampak tak?
Nampak.
Okay. So molecular shape is after we consider lone pair. Tak apalah. Tak apalah saya tak tulis je lah benda ni. So you guys faham je lah. Tulislah dekat molecular shape tu is after you consider lone pairs. Okay. Electron pair geometry is kita basically tengok how many, kita totalkan semua. Berapa dia ada bonding, berapa lone pair dia. Tak kisahlah dia one bonding, one lone pair pun kita totalkan semua. So kalau one bonding, one lone pair, dia ada dua electron pair. So the first, kalau kita ada dua is linear. Yes, linear. Wow. Okay, so linear. Kalau number of bonding pairs dia 2 and number of lone pairs dia kosong. Okay, macam mana tu molekul tu? Well, the general formula yang a lot of buku tulis is A for central atom, and then bilangan central atom tu you don't need, you tak payah tulis because most of the time kita ada satu je kan central atom, and then X as the terminal atom. So kalau nak contohlah the molecule ada dua bond, so you rasa ada berapa terminal atom?
3. 2.
Ada dua kan?
Dua.
Sebab dia ada dua bond. So maksudnya example is A, X. Okay. kita simplifykan dia sebagai, kita tulis terus dalam bentuk AX2. Maksudnya AXX. Samalah macam H2O. Tapi kita tengok later kenapa H2O is not linear. H2O, saya tengok balik nanti, is a special case. Okay. So, cara the simplest way is kita letak AX2. Sebab lone pairs dia tak ada. Okay. So, the name, kalau tak ada lone pairs, apa saja molekul yang kalau dia tak ada lone pairs, the molecular shape punya name will be sama as dia punya electron pair geometry punya name. So kalau dia tak ada lone pair and dia start adalah linear, it still will be linear. It is linear. So, and then dia punya shape is, kalau you ingat tadi, linear is dia bentuk dia like this, bentuk sebaris. That's why we call linear. The clue is in the name. Dia bentuk line. Dia sejenis line. Dia semua duduk dalam sebaris. And the bond angle is 180. Okay. Contohnya is carbon dioxide. Kalau you buat Lewis structure, you dah completekan octet, you will get like this. Okay, for this, tak kisah dia double bond or triple bond, kita still kira kalau contoh C, dia bergabung dengan satu oksigen and then the second oksigen, kita kira dia as satu. So, single ke, double ke, triple ke, semua kita kira sebagai satu pair. Even though kalau you tengok, this one is 2 elektron kan, this one dah 4, this one dah 6 kan itu. Tapi, for molecular geometry, tak kisah berapa banyak bond, double ke, triple ke, kita still consider dia sebagai satu bond. Sebab, apa yang kita tengok sini is only dia punya berapa banyak dia bercantum and berapa banyak lone pair yang dia ada. So, dia tak ada langsung lone pair, tak adalah. Okay, apa jadi kalau dia ada satu lone pair and dia ada satu bonding pair and satu lone pairs? It is still linear, okay, sebab 1 tambah 1 still 2. The number of electron pair, so the electron pair geometry still 2. Kenapa saya tak tunjuk? Sebab it would not change anything. It will be still linear. We're just replacing this dengan lone pair. Tu je. Kalau this one lah. So kita tak tengok this. That's why saya buat sampai bonding pairs yang paling kecil is 2 je. Okay, boleh?
Boleh sir.
So now kita tengok untuk 3 pula. So 3, we will get the electron pair geometry is trigonal.
Trigonal planar.
Yes. Trigonal planar. Macam awak punya assignment tu kan. So, the number of bonding pair is either all of the pairs are bonding and tak ada lone pairs, ataupun hanya 2 of those pairs are bonding and 1 lone pairs. Okay. The general formula is A, which is for the central atom, X for the terminal. Kalau ada 3 bonding, ada berapa?
3 bond.
Yes, very good. And this, kalau kita tengok, ada 2 bonding, kita letak just ada 2 bond. And then the lone pair, some books guna E, some books guna B. Okay, so saya guna E lah, because most of the book guna E. Kalau you tengok A, X, B pun sama. B tu is bonding pairs. So usually orang akan letak central atom, terminal atom, and then lone pairs. Okay, so since this one, dia punya molecular shape, dia tak ada lone pair, So it will still be the same. It will be still trigonal planar. So bentuk dia macam kita tengok tadi, okay. And kita buat bentuk Y dan X 120. Kat mana-mana pun you boleh buat angle sebab angle dia sama 120 degree. Okay. For this, now they start dengan trigonal planar, but one of the terminal atom is replaced with lone pairs. So what happen now? Yes, okay, contohlah mana-mana atom pun boleh replace sebab dia orang ni sama. Semua orang duduk dekat angle yang sama. So, contohlah saya ambil satu bawah, yang bawah saya gantikan dengan lone pairs. Okay. Saya gantikan dengan lone pairs. Okay. Now, kalau you tengok lone pairs, it wouldn't show. So the shape tu, molecular shape yang kita tengok tu is basically the terminal, the central atom dengan terminal atom je. So kita call this shape is V shape or bent molecule. Either way betul. Okay, because setengah buku guna V shape, setengah buku guna bend. Sebab V shape kalau you tengok dia bentuk macam V. Nampak tak V? Ataupun setengah buku guna bend because basically instead of straight macam ni, instead of straight linear, it is bent. Dia macam naik atas sikit. Okay, boleh tak?
Boleh sir, boleh.
Okay. Now, if you remember, lone pair to lone pair repulsion is bigger than lone pair to bonding pair, and then bonding pair to bonding pair punya repulsion is the weakest. Okay, since now instead of bonding pair, kita dah ganti one of the bonding pair with lone pairs. So kalau you tengok lone pairs dengan bonding pairs tolak lagi kuat daripada bonding pair dengan bonding pair. So now what happened is these two bonding dia akan bergerak ke sini sikit. Dia nak mengelak daripada lone pair ni. So ni ibaratlah, so bonding pair ni ibarat orang yang mandi lah, wangi. Pagi dia mandi wangi-wangi, handsome, comel-comel. Lone pair ni pula macam orang yang bangun pagi, serabai, belum gosok gigi, so dia busuk. So bonding pair ni tak nak duduk dengan orang busuk. And orang busuk pun tak nak duduk dengan orang busuk. Sebab kita boleh bau kan kalau orang lain busuk. Diri kita je kita tak boleh bau. So this bonding pair pun dia nak duduk jauh. So now instead of 120, the way that tulis is less than 120 degrees. Okay, it's less than 120 degrees. Sebab, nampak tak? Lone pair and bonding pair repulsion is way bigger than bonding and bonding. So now this thing push the bonding pair stronger than this push the bonding pair. So bonding pair push the bonding pair is weaker than lone pair push the bonding pair. So the angle kita tulis is 120. Okay, each of the molecule has specific angle lah. Because kita ambil kira pasal size, kita ambil kira pasal electronegativity. So, tapi for now untuk molecular, untuk 7.2, cara yang you guys tulis, just tulis this one je. Is less than 120 degrees. Sebab kita ada lone pair yang tolak dia. Okay, boleh tak? So, the example is tin fluoride. Okay. Now, we go on. Daripada kita ada dua je total electron pairs and 3 total electron pairs, kita tengok ke what if kita ada 4 electron pairs. So 4 ingat tak tadi apa nama dia? Boleh siapa tadi? Yes, tetrahedral. Tak cukup. So tetrahedral kita can have 3 variation. So first is always kita tak ada langsung lone pair. So 4 of all of those pair are bonding. Or kita ada 3 je bonding, 1 of those are lone pairs. Or kita ada 2 bonding and 2 lone pairs. So the class of molecule, central atom, and then kalau kita ada 4 bonding, maksudnya ada 4 terminal atom kan? And dia tak ada lone pairs. While this,
3 terminal atom.
Yes, E. E you boleh tulis 1 ataupun tak tulis pun tak apa, because 1 is still the same kan? For A, X, E, 2. Okay. For now, you guys tak, I'm telling you lah, because nanti sem ketiga baru you guys perlu ada soalan yang tanya pasal class of molecule. So I'm teaching you early lah, because right now untuk sem pertama kan? Kedua? Pertama. Sem pertama tak ada lagi soalan yang akan tanya class of molecules. Nanti untuk sem ketiga memang akan tanya. So right now is just penting je untuk tahu je lah. Okay. So now, bila je you tengok tak ada lone pairs, the molecular shape punya name is still the same as dia punya electron pair geometry. So it is still tetrahedral. And tadi kita dah lukis tetrahedral. And the central atom, kita pick any 2 atom that it is in plane. Okay. And then kita ada 1 is depan ke kertas, aka menuju ke kita. And the other is belakang kertas tu, which is menuju away from us. Okay. Now, bila kita replace one of the terminal atom with lone pairs. So what happened is kita boleh replace mana-mana satu. So usually kita akan replace the atas sebab it's easier for us untuk lukis. So kalau you tengok, this X and the lone pair still in the same plane kan? Only these 2 are out of plane. Satu depan, satu belakang. And so apa nama yang kita beri kepada benda ni? Kalau you tengok, you nampak tak? As nama kita beri, kita tak kira lone pairs. So kita bayangkan lone pairs tu tak wujud.
Ya.
So kalau you tengok, ini bentuk actually macam trigonal pyramid. Trigonal pyramid. Okay, and then tetrahedral kita just kena hafal dia punya bond angle is 109.5. Now kita ada lone pairs, they push harder, so the angle is less than 109.5. Okay, I will show you why it become trigonal pyramid. Okay. Okay, can you see my screen? Nampak muka saya?
Ya. Nampak.
Okay, so this is the tetrahedral. So dia bentuk dia kan tetrahedral. So now what happened is kita replace one of the terminal atom dengan lone pairs. So lone pairs, bayangkan the lone pairs ini. So right now the one that left is, so from tetrahedral bila kita dah ganti, apa yang tinggal is this. So it's not exactly trigonal planar, because if you remember trigonal planar bentuk dia is like this kan. Every single atom are in plane, but now even though dia ada 3, it is slightly bent. Nampak tak?
Oh, faham.
Okay. Kalau kita originally ada 3, kita buang satu terminal atom, kita akan dapat band kan. So basically the general idea you guys nak fikir is, kalau ada lone pair tu ibarat you buang satu atom. So you buang satu atom, tinggal bengkok. Tapi kalau dia start dengan ada 4 pairs, tak kisahlah 4 pairs tu is bonding ke lone pairs ke, tapi dia start dengan 4, the original shape is this, is always this, even though dia cuma ada 3 atom. So 3 atom dia bentuk macam ni. That's why we call trigonal for the bentuk 3, 1, 2, 3 segi, trigonal pyramid. It's not bipyramidal ke apa semua, it's pyramid ataupun pyramidal. Sebab kalau you tengok, okay, nampak tak, it's not exactly on top of the plane. Dia macam ada piramid bawah tu kan, nampak?
Ya, nampak.
Okay, that's why we call it trigonal pyramid. So kita continue buat. That's why the name is trigonal pyramid. So bila ada lone pairs je, kita ibarat form the original shape. So electron pair geometry is the original shape, and the molecular shape is the one yang after electron lone pairs. So that's why now from tetrahedral kita buang satu, it become trigonal pyramid. So the angle is less than 109.5. So now what if kita buang lagi satu and kita ganti with lone pairs? So kita dah ada satu lone pairs ini, and kita buang lagi satu. Okay, this is actually, you guys dah nampak dah bentuk ni. Actually this bentuk is the same as V shape. Ni still bentuk V. Kalau you guys tengok betul-betul, nampak tak dia bentuk macam V?
Bawah tu.
Okay, the name is still the same. It's either V shape or band molecule. Okay, every time you tak perlu tulis V shape or band molecule. Tak kisah you nak guna V shape ke band molecule ke, mana-mana betul. Sebab saya tulis dua-dua ni sebab buku tak semua guna V shape, tak semua guna band. Okay, but the only thing that is different now, instead of tadi kita tulis is less than 120 degrees kan. Now sebabkan dia start dengan tetrahedral, so it is less than 109.5. Sekejap, tak cukup tempat lah. Sekejap, mana pemadam. Okay, so sebabkan dia start dengan 109, is still 109.5. Tapi now sebabkan kita, yes, dia kurang, tapi dia mesti lagi kurang dari ni kan, sebab dia ada dua lone pairs. So you get kurang ni 2. So dia kurang daripada 109.5. Sebab kalau you ingat, lone pair to lone pair repulsion is the highest, and then lone pair to bonding pair, and then bonding pair to bonding pair. Because tadi kita just ada satu je lone pair, so ada satu je lone pair yang tolak bonding pair ni. Sekarang kita ada 2 lone pairs. So kita ada dua lone pair yang tolak, and also this lone pair and lone pair pun also push each other the hardest. Paling kuat dia orang tolak is lone pair and lone pair. So that's why you buat kecil and even kecil than 109.5. Okay, boleh. So that's the only thing you guys kena remember. Kita always start dengan the most basic punya shape, which is tetrahedral, sebab kena ada 4 pair, and ingat dia punya angle. So any lone pair yang kita tambah pun is based on the initial angle, is based on the initial shape. So from tetrahedral jadi trigonal pyramid, then jadi V shape or band, then the angle is less than 109.5. So angle dia dekat sini ataupun dekat sini, and then this one is the smaller than 109.5 is dekat sini. Okay, boleh?
Sir.
Ya.
For tetrahedral macam ni
Sekejap saya tengok awak punya. Tengok awak punya macam mana Okay, macam mana? Oh, you cannot. Okay, kalau Daniel, can you show it again? Semua orang boleh nampak tak kamera Daniel?
Nampak.
Okay, kenapa you tak boleh draw like that sahaja? Okay, so let me show it here. You still nampak my tu words ni, get handout ni?
Nampak.
Okay, kenapa you tak boleh lukis macam ni? X. Lukis like this does not mean a 3D molecule. Because molecular shape kita minta is 3D. This is still 2D. Okay, kenapa? Because for now, so far that I know, every single atom here is duduk atas plane of paper yang sama. So A duduk sini, and then dia ada maybe angles dia, I don't know, maybe this one 120, and then this one maybe 80 ke, this one maybe 70, this one maybe 60, apa?
Saya nak tunjuk PowerPoint kan?
Saya tunjuk,
Siap. Tulis.
saya tunjuk PowerPoint ke?
Dari
tadi ke? Kenapa korang tak bagi tahu? Saya punya lah tunjuk. Check handout ni. Ni. Saya punya lah lukis-lukis benda ni. You guys nampak tak saya lukis-lukis benda ni? Ya Allah, korang tak beritahu saya.
Tengok yang dekat PowerPoint je.
Kami ni rasa buka PowerPoint kami tengok.
Ya Allah. Tak apa, yang lepas-lepas tu nanti korang tengoklah saya upload video ni nanti. Boleh tak beritahu saya. Okay. Where should we go? Okay. How about this one semua korang tak tengok lah tadi. I'll go through.
Ada tengok lagi.
So this one nampak my words lah. Nampak my, bukan PowerPoint kan, words kan, nampak kan?
Words.
Okay, tak apalah. Kita go through. Okay, this is apa yang saya tunjuk tu pasal dia punya soalan. Kenapa kita tak lukis macam ni? Sebab it's not showing a 3D molecule, it's showing a 2D molecule. By showing only the bonds, kita tak show that the bonds tu macam bukan depan the other atoms. By showing this, we are showing that all of the bonds are on the same plane. Kalau atas kertas tu semua duduk macam ni. So the angle dia tak sama lah, semua macam tu. Okay, that's why kita guna wedges and dashes untuk tunjukkan the orientation in space. Nak tunjukkan this atom depan kita, this one is belakang kita. Okay, kalau siapa nak salin tengok ini sekejap. So ini nampak kan? Bagi tahu lah, macam ada fobia lah korang ni.
Nampak.
Okay. So it's called V-shape or band molecule. So dah habis lah. Saya nak go to 5 ni.
Okay.
Masih bila korang bagi tahu juga. Korang sampai habis lah korang tengok PowerPoint tu. Yang keempat je lah korang tengok. Dah habis? Dah habis ke?
Dah. Dah.
Okay. I'm going to 5. So, kalau 5, okay, sekarang dah tak ada answer kan? Kalau 5, apa nama dia?
Trigonal bipyramidal.
Yes. Okay. For the nama, you guys have to hafal. Trigger. First dengan linear, and then trigonal planar, and then tetrahedral, and then trigonal bipyramidal. Okay. Macam tadi saya tunjuk, trigonal pyramidal maksudnya dia ada piramid yang 3 segi, and bi maksudnya 2. So kita ada 2 piramid yang 3 segi. Tapi that's only for the electron pair punya nama. So, kalau dia ada 5 pairs, tak kisahlah bonding atau lone pairs, we can have all of the 5 as bonding and tak ada lone pairs. Ataupun dia ada 4 je bonding, 1 lone pairs, ataupun 3 and 2, ataupun 2 and 3. Okay. So, class of molecule sama macam tadi. Biasa kita guna X as the central atom, and then X berapa bilangan bonding dia, jadi 5. Okay, can you guys do for this and this and this, the class of molecule?
Boleh.
Okay, since saya tak nampak korang, so bagi tahu jawapan.
E1, E1,
Okay. Okay, do you get it? That A is always central atom. The second one, kita almost every book akan represent as X, which is the terminal atom, atom yang keliling dia, and E as the lone pairs. Sometimes orang letak B. Okay, E ataupun B. So basically, tak kisahlah. The huruf yang ketiga usually they represent lone pairs. Okay, so now apa nama dia untuk molecular shape? So dia tak ada lone pairs, maksudnya dia tak distorted in any way. So it is still trigonal bipyramidal. Okay, macam assignment awak, semua molekul tu tak ada lone pairs kan? So every of those molecules are not distorted. It is all of those are basic shape. So cara nak lukis is kita letak dulu dia punya central atom, which is this one, kita letak A as the representative, and then for the trigonal bipyramidal, you letak dulu that axial punya terminal atom, and then kita letak 1. So, the general rules untuk lukis trigonal bipyramidal, you buat T dulu. So, you buat T, and then now baru you lukis the two terminal atom yang depan the plane and belakang plane kita buat wedges. So, that's why cakap is trigonal bipyramidal. So, kita ada piramid dekat atas dan piramid dekat bawah. Okay, sebab the shape is you guys tengok dia ada two. Okay, sekejap saya nak stop presenting. Can you guys see my camera? So, do you guys see that? Nampak tak? There's two groups of atoms untuk trigonal bipyramidal. Satu for the atoms yang straight, and then satu for the atom yang buat tiga segi ni. Nampak tak? Satu for atom yang buat tiga segi ni, satu for atom yang buat straight. That's why kita ada piramid atas and piramid bawah. Okay, so nanti when kita replacing the atoms, kita replace the one yang the furthest away. So, kita akan replace, kalau you tengok the angle here and here is 90 degree kan. So, here and here 90 degree, here and here 90 degree. So, bila kita replace dengan lone pair, kita akan replace yang tiga ni. Kita akan replace yang banyak lagi. Daripada kita tak akan replace yang ni as a lone pair. Kita akan replace this one. So, trigonal bipyramidal is the one yang you guys kena fikir balik mana dia akan replace. Sebab ada molekul kita boleh je replace mana-mana. Sebab they have the same bond angle. This is the only molecule yang ada dua bond angle, 90 degrees and 120. So, nak fikir which one yang kita akan replace, tengok yang mana banyak. Yang ada dua ke yang ada tiga. So, since tiga yang banyak, so kita akan replace yang tiga. So, that's why kita akan replace. Contohnya satu, jadi lone pairs. So, this is the molecule. This one, nanti kita akan tengok, is called seesaw. Sebab bentuk dia macam seesaw. Tengok sekarang. Okay, sekarang bentuk dia macam seesaw. Nampak tak? Jongkak-jongkit. Yes. Okay. And then, for example lah, you ada lagi satu lone pairs. You will still buang form yang tadi. Tadi ada tiga kan? Dia akan buang form this juga. So now, dia akan bentuk T-shape. Nampak tak? Dia bentuk macam huruf T. So, and then the third lone pairs pun you akan still buang form tadi, tempat yang tiga tadi. Ingat tak? Tiga tadi, kita buang semua. Dia akan still buang dekat situ juga. Dan sekarang kita akan dapat linear molecules. Okay, boleh? Boleh lah. Bagus. Okay, saya present balik. Let me know you guys nampak tak? Please nampak Nampak handout kan? Ikan ni nampak. Okay, nampak handout. Okay, so macam tadi, form trigonal pyramidal, which is the bond angle kita ada dua, so 90 degrees and 120. So 90 degrees and 120 degrees. So now kita hanyalah buang kita hanyalah replace the atoms yang dekat 120 degrees ni. Sebab dia orang lah paling jauh. Kalau you tukar yang 90 degrees ni, the lone pairs akan still 90 degrees kan? 90 degrees lagi dekat kan daripada 120s. So, you replace any of these three terminal atoms dengan lone pairs. So the easiest way is you replace the one yang dekat on plane. Nampak kan words? Saya lukis ni.
Ya, sir, words.
Okay, good. Okay. And macam tadi, dia bentuk seesaw, jongkang-jongkit. Ini papan jongkang-jongkit tu. Ini dia punya fulcrum. Ini bengkok kan. So, kita dia bentuknya seesaw. And the angle, okay, angle dia is still the same for 90 degrees. Tapi apa yang kurangnya, ini dia duduk dekat plane yang equatorial kan, dia akan tolak this 2 bond away. So it can be less than 120 degrees. Okay, boleh. So for if kita sekarang ada dua lone pairs pula, instead of satu, the lone pairs will always sit dekat sini dulu. Dia akan always sit dekat plane yang 120 degrees tu. So now kita will have always the same. Okay. Nampak tak? Saya replace one of the equatorial terminal atom dengan lone pairs. Okay. So jangan lukis lagi this one because there's an easy way untuk lukis. Ini saya nak tunjuk korang apa yang saya replace. So the easier way untuk replace is kita lukis T. So okay, so kita lukis T. And we have two lone pairs. Okay. It is the same molecule macam tadi. Cuma instead of belakang plane tu, kita pusingkan dia, masukkan dia dalam plane balik.
T-shape.
Yes. So for T-shape, this one is, we call it T-shape. So for the angle, sekarang kalau you tengok, kita dah tak ada dah yang terminal atom yang 120 degrees. So apa yang tinggal is atom with 90 degrees. So what happened now? This one is not only tolak here and here, it's also tolak here and bawah. So the only angle is less than 90 degrees. Okay. Boleh?
Boleh, saya boleh.
So now kita nak tengok what if kita ada 3 pula lone pairs. So lone pairs tu always duduk dekat pinggang ni. Ini ibarat pinggang dia, ni kepala kaki dia kan. So okay, saya lukis. So ibaratkan the lone pairs duduk keliling dia. And tadi saya tunjuk, sekarang dia dah jadi bentuk. Kalau you tengok, bentuk dia is only for central and terminal atom. You tak tengok lone pairs. So now it has become a linear punya molecules. which is dia punya angle is 180. Okay, boleh tak?
Boleh kan? Wait.
Okay, saya tunggu. Sekarang korang nampak words kan? Betul tak?
Ya, saya masih nampak bukan PowerPoint.
Okay, good. So, dah habis ke Saleh?
Yes.
Okay, I'll go to now. Kalau ada 6 pula. Because in your syllabus, kita belajar sampai 6 je. But, you can have 7, you can have 8. 9 is, I don't think so. Susah lah sikit. You can have sampai 8 ada. That one nanti kalau you guys belajar transition method. Okay, so now 6 is very simple. Kita akan dapat octahedral. So octahedral, we can have all of these 6 pair as bonding pair, and tak ada langsung lone pair, ataupun kita ada 5 je bonding, 1 lone pair, ataupun kita replace 2 of those bonding become they become lone pairs, or kita replace 3 of those bonding jadi lone pairs, or ataupun kita replace all 4 of those bonding jadi lone pairs. Okay, kalau tengok this all still total as 6. 4 tambah 2, 6, 3 tambah 3 semua tu kan. So now kita tengok class of the molecule, you already can figure it out kan. Okay, X now. Okay, this one berapa?
AX5 E1.
Yes. And fill out the other class of molecule. Okay, boleh tak? So now the molecular shape, tak ada lone pair, it will still be the same. Dia takkan berubah. It's still octahedral. So cara yang you nak lukis is the most widely used. Paling cantik is always you lukis dulu central atom and then yang atas dulu. X, then X. So, dia bukannya bentuk, ni ibarat, remember tak hari tu saya ajar cara nak lukis axis untuk orbital. You buat garis and then you buat X kan?
Yes.
So, this is also the same kalau you tengok. Bentuk X. Okay. Sebab, 2 atoms depan kertas, 2 atom belakang kertas. So, like this. So, the angle, kalau you tengok, tadi kita ada 3 kan, for trigonal bipyramidal. That one sini angle dia 120. So, bila kita tambah lagi 1, apparently, all of these angles are the same. We only have 90 degrees. Each of these atom are spread out at the same degree. Diorang semua duduk betul-betul elok. Sebenarnya kalau you tengok dia dah boleh jadi kotak dah. Okay, and then now instead of all of these are bonding, one of the bonding kita nak tukar dia jadi lone pairs. So you can pilih mana-mana. So most of the buku kita buat dekat bawah dulu sebab is easier representation. Okay, kalau you tengok bila you replace one of the terminal atom, you boleh replace mana-mana sahaja. Excuse me. The only one yang you kena pilih nak replace yang mana is trigonal bipyramidal, which is you replace dekat pinggang. The other atom you boleh replace mana-mana sahaja sebab semua angle dia sama. Baik, only trigonal pyramidal je yang you kena replace dekat pinggang. Sebab dia ada dua angle kan. So ini ada just one angle. So kita boleh replace mana-mana je. So the easiest way kita replace is dekat bawah. So now what you can see now is actually dia dah tukar shape. Okay, I'll draw this mapping ni. You tak perlu draw, okay? This, okay, ibaratkan this is your plane. Okay, nampak tak sekarang apa yang awak buat, instead of tadi kita buat trigonal pyramidal, you buat square pyramidal. Piramid yang bentuk square. Nampak tak? So that's hence the name is, you guess it, is square pyramidal. Okay, dalam buku maybe kalau you guys buat soalan nanti, some buku will tulis square pyramidal. Apa-apa yang ada piramid tu sometimes dia tulis pyramidal. Dia macam tambahan. Some buku dia just tulis square pyramid. Square pyramid ke square pyramidal, both are accepted. Okay. Now macam tadi saya, so lone pairs to lone pairs is the highest, and then lone pair to bonding pair is the second highest, and then bonding pair to bonding pair is the weakest. So now, since awak ada lone pair, dia akan tolak this angle, all of this terminal atom jadi macam nak rapat, macam awak nak tutup payung. So it will be less than 90 degrees. Okay. Now, kita nak tambah lagi satu lone pairs. So you guys rasa dekat mana kita nak tambah? Sebab kalau you guys ingat balik, valence shell electron pair repulsion theory, apa yang dia cakap? Dia nak minimize the repulsion as much as possible. So kalau you guys letak sini, dekat tak lone pair tu? Kalau you letak lone pair tu dekat sini, dekat kan dengan sini? So dekat mana you nak letak lone pair yang boleh jarak dia jauh?
Atas dan bawah.
Yes, very good. Atas and bawah. So now apa yang lone pair tu akan duduk is dekat atas and dekat bawah. So you guess balik you punya terminal atom. Okay. And the sheet is now, kalau you tengok, it is actually now dah jadi square planar. Sebab bentuk dia square and all of the atoms are in a plane. So it is square planar. Okay, and now the angle pula. So what happened? Actually, the angle revert back to the normal angle. Kenapa lah pula? Okay, you tengok this one. This ada satu je lomper yang kuat tu tolak semua molekul ni ke atas macam nak tutup payung. But now, kita ada satu balik lomper ke atas untuk buka balik payung tu. So this atom, this sandwich. So they have the same amount of repulsive force. Nak tolak this one ke bawah and this one tolak ke atas. So they orang cancel out each other. So that's why we got 90 degrees of angle to this on each of the terminal atom. Okay, boleh?
Boleh.
Dah habis ke? Habis tak?
Tak.
So I'm going to the final two. So now, daripada 2, kita ada 3 pula. So, kalau 3, since kita letak atas and bawah kan? Atas and bawah kita dah letak bonding pairs. So now, you actually boleh letak mana-mana je yang you nak. Okay. So, jangan salin lagi, okay? Yang ni. I boleh letak sini. Okay. This one jangan salin lagi because saya tunjuk the easier way untuk lukis. Okay, kalau you tengok, actually this one, if saya lukis using this plane ni, okay, actually these 3 atoms are in T shape. Nampak tak bentuk T ni? Kalau dia orang duduk atas plate. Nampak tak?
Nampak.
So, the easy way untuk lukis this is kita padam balik. So the easy way untuk lukis this is the terminal atom and then X and X. One of the terminal atom as wedges. So you nampak tak T-shape? Bentuk dia. So now kita lukis dia punya lone pairs. Okay. So the molecule is T shape. Okay, boleh?
Oh, kalau kita tadi kan? Yang atas bawah ni?
So macam tadi, nampak tak? Kita letak atas bawah. And then sekarang kita ada 4 yang kita boleh pilih, yang mana satu kita nak ganti as lone pairs. So for example, saya ganti this one. So nampak tak? This one is actually T-shape. Okay, jadi saya tunjuk using my models. Okay, let's finish this first. So the angle is less than 90 degrees. And now, if you look at it, kalau you ada lagi satu lone pairs. So, kalau you letak sini, it will be dekat sini. So 90. So the next possible step untuk letak lone pairs is here. So which is you akan dapat A X X here So right now, your molecule is actually a linear molecule. Dia tengok straight je. Sebab kalau kita tengok molecular shape, kita tak tengok lone pairs. Kita ibaratkan lone pairs tu tak wujud. So it is 180 degrees linear. Okay. Boleh tak?
Boleh sir.
So, dah habis salin tak? Okay, saya nak tunjuk my model.
Dia dah, dia lain tak tahu.
Okay, bagus. Give it one more minute untuk salin. So, I will stop presenting and show you my modules. Okay, now, this is octahedral. So, when you want to start replacing this terminal atom with lone pairs, you can pick any atom. Sebab kalau you tengok, this one 90 degrees, this one 90 degrees, semua 90 degrees. So, example lah, saya ambil the first one, saya ambil bawah. So, saya buang from bawah. So, now, kalau you tengok, yang tadi saya tunjuk, it is square pyramidal. Nampak tak bentuk piramid? Okay. So, nampak bentuk piramid. Now, kalau you buang sini, cabut macam. Kalau you buang sini, nampak tak? This lone pair dekat dengan this lone pair. Dia orang tak suka. Sebab based on VSEPR, kena letak as far apart as possible. But lone pair dengan lone pair is very repulsive. So, kita letak dekat atas. So, nampak tak? Sekarang, dah jadi square planar. Sebab semua atas plane. Semua plane yang sama. So, now you dah buang atas and bawah. Now, you boleh pilih lah yang mana-mana satu. Tak kisah. So, for example, saya buang sini. Benda lain tercabut. So, saya buang sini. Tapi, right now, you nampak tak sekarang? It is actually T-shape. This holes represent the lone pair. Sekarang dah bentuk T-shape. So, it's easier way kalau you nak lukis like this. And then you lukis one dia punya lone pairs going out the plate. And then one dekat depan and the other one dekat belakang. Okay, now bila saya nak buang ni, saya nak letak lone pairs, saya usually akan letak at the same plane lah. Because kalau saya buang sini, this lone pair and this lone pair will repulse greatly. So dia orang tak suka. Dia orang tak suka duduk dekat-dekat. This one and this one tak suka. This one and this one tak suka. So what I did is untuk letak them as far apart as possible, saya letak dekat sini. So now my lone pair is cleaving this atom, and this atom now has become linear value. Boleh?
Boleh.
Okay, do you have any question about this? Okay, now kita dah habis. Any part yang you guys tak faham? Oh, very cantik dia. Okay, so one thing I nak ingatkan, nanti for part A, for assignment dia ada part A and part B kan. Part A, don't only hantar you punya jawapan, also hantar the student declaration tu. Ingat tak saya hantar? And you guys kena tulis nama, sign. So that one is easy to print it out, tangkap gambar, gunakan scanner ke apa, saya nanti, and then hantar sekali part A. So part A saya nak yang the student declaration and you punya VSEPR and the drawings lah. And then part B just hantar dia punya link. Okay, do you have any question?
Yang tarikh tu kan?
Yeah.
Nak tarikh ke?
Tarikh last hantar.
Tak, dekat ada paper yang kena sign tu. Yang tu kan ada taran kat tepi tu. Taran tu nak tak taran tu.
So
Taran tak?
that one, contohlah you guys dah siap semua. So you hantar today. By siap semua tu is you dah siap dengan video sekali. So bila you dah siap part A and part B, baru you tulis, you tanda tarikh and you hantar. Okay? So that is when you dah siap every single part of the assignment, you dah hantar everything. And you hantar dekat dia punya itulah part A and part B. So for siapa yang hantar dia orang punya draft dekat part A and part B, you guys can resubmit. So don't worry. Because that one, kalau saya write itu, that is your final mark. So anyone else ada any more question? Is it clear pasal drawing today? Okay, besok dah tak clear dah, dah ingat. Okay, so that's it for our class. Thank you for coming. I'll see you Thursday. Okay, Thursday nanti saya akan show one very cool software you guys boleh guna, and it's free untuk lukis-lukis the structure ni. You guys boleh main. Okay, so I don't think there's anything else. Tak ada apa kan soalan? Okay, so thank you for my class and see you guys Thursday. Okay.